5.3 here, we're still working with z-scores again with our normal distribution, but now we're doing it from a little different perspective, doing it backwards. We're talking about the probability or areas related to the graph, so we already know that information. Now this time we've got to use the area or the probability here to then calculate the z-score. So whenever we're looking at our chart here, we're going to be doing it backwards in terms of how we're going to look up these values here. So first of all here, if we have a z-score that we're looking for, and we're looking for 32% of the data above it, we're thinking of it here on our normal curve here. It'd have some value here, be above the mean in this case because it's more than 50% is going to be below it because there's 32% above it, or 0.32 as a decimal would be the area to the right. Remember, if you're talking about at the mean splits it in half, so there'd be 50% above, 50% below. So if we're talking about the top 32% or 32% of the data being above that value, we talk about up here. So this z-score here, it better be positive whenever you're calculating it here to have 32% be above that. So one way to find that here is we could look up 0.32. And whenever we're looking at 0.32, you're not looking at it along the side like we were before. We're not looking at the z-score. We're looking in the middle area of the chart here. And if we're looking for 0.32, we're going to have to look on the negative z-score side to begin with here. And we're looking at 0.32. We're trying to find the area in the chart that is closest to 0.32. So a lot of times there'll be two values that'll be really close to it. They're not always going to be exactly the value. So if we're looking up an area that's close to 0.32, one of them that's close to it in the chart that we can subtract from 0.32 to see which one's closest would be 0.3192. Once again, you're looking in the middle section of the chart this time instead of along the sides, looking at the areas. And then we could also do our 0.32 and subtract the other one that's close to 0.32 if you're not sure which one is closer right off the bat here. So the other one was 0.3228 was the other one that's close to 0.32. And it's not necessarily going to be the one that's above or below that value. It's just whatever one's closer. So whenever you're going through and subtracting these, so like here in this case, whenever I subtracted it, my calculator gave me that it was 8e negative 4. If you get that symbol, write it off to the side. If you have 8e and then negative 4, that's the same type of thing as your scientific notation. It means you're going to have to move that decimal point to the left 4 places. So this really represents the number 0.0008. So if you're starting at behind that 8, move that decimal point over to the left 4 places since it's negative 4 there. So if you see that symbol, that's the same thing as your scientific notation there. And then we also want to do our 0.32 minus the 0.3228 there. If we do that here, we get negative 0.0028. Once again, you're just looking to see which one is closer to that number. So in other words, you're looking to see which of these two numbers here, whenever you subtracted it, are closer to 0 in absolute value. So it doesn't matter if it's negative or positive, you're looking for which one's closer to 0, because then that means it's closest to this 0.32. So in this case, if we're looking at which one's closer, this one is definitely closer, really, really close to 0 in terms of that value. So then what you'd want to do is you'd want to look back in the chart to see what the z-score was that was corresponding to this value of 0.3192. So if we look back there at the one that said 0.3192, we have to go over to the left in the chart and then up to see what the corresponding z-score value is for that. So the corresponding z-score for that, if we're looking at the chart here, looks like would be a negative 0.47, because if you go over to the left from that value, you get a negative 0.4, and then if you go up, you have the 0.07. So that means it corresponds to a z-score there of a negative 0.47. But like we said here, instead of it being the bottom 32% or have 32% below it, we wanted it above it. So really what we just found here would be if we're looking for 0.32 down here, and that would be at a z-score of negative 0.47. For that z-score. So if we want 32% above it, it's just positive of that because the graph is symmetric for a normal distribution curve. So in this case, for a z-score that has approximately 32% above it rather than below it, it would have to be the positive of that. So you'll want to look up your value. Once again, we converted that 32% to a decimal first, so that way we could then look up the area. And we had to look to see which one was closer to the 0.32. That top one there was closer. We found the z-score that corresponded to that value. And then since we wanted 32% above it rather than below it, we had to use that positive value there. So some of these get a little bit tricky at first. So you want to make sure you keep track of all those steps. Definitely want to make sure you have a good understanding of sections 1 and 2 of this chapter first before you get started on this section here. So for the next one there, we wanted to find the z-score that corresponds to the 32nd percentile. So we talked about percentiles a little bit before. Remember, for a percentile, that means that you'd have 32% that scored below that score. So in other words, that represents 0.32 down here. And we already found that here in example 1, that was a z-score of negative 0.47. So sometimes it'll give it to you as a percent and then tell you whether you're above or below that value that you're looking at. Or if you're talking about a percentile, percentiles is always giving you the percent that was below that value, or what percent of people scored below that score if you're thinking of it in terms of a standardized test. So here, since it's 32% below it, that would mean that it would have to be below the mean. So you have a z-score that is negative there. Because remember, if you're at the mean would be in the center of that instead, which would split it in half, 50-50. So make sure you keep track if you're on the positive or negative side of your chart there in terms of your z-scores. For example 3 here, we're using this example that we did in section 5.2, where we did a survey of 150 students, and we had average GPA of 2.7 and a standard deviation of 0.72. And we want to figure out this time what the minimum GPA you would need in this group to be in the top 15%. So the top 15%, if we're thinking of it here in terms of our normal distribution curve, what we're going to have there is that we're going to have 0.15 to the right of our value there. So whenever we're doing our curve here, we'll have some value. We'll have to figure out what that z-score value is there first of all. That corresponds to 0.15 being to the right of that value. So once again, since we're on that right-hand side of the mean, we're going to need a positive z-score there for that z-score value. So once again, we can look up in our table, see which value is closest to 0.15 first of all. So that'll be on the negative side of the chart here. So we have 0.15 that we're looking for, or whatever is closest to it. Once again, if you're not sure which one is closest, you're going to want to go through and subtract it from the 0.15, see which one gives you an answer that's closest to 0. In this case, we had two of them again. We have a 0.1492 and a 0.1515. In this case, the 0.1492 is closer to the 0.15, so we're going to want to use that z-score value. That one in the chart gives it to you as a negative 1.04, but we're on the positive side here since we're talking about the top 15%, so we want to use positive of that value. So once again, in the chart, the area that was closest was the 0.1492. That was for the area that was closest to the 0.15. And then you had to go over and up to find that corresponding z-score. So that z-score, once again, from the chart was negative 1.04. But we're in the top 15%, so then we wanted to use the positive 1.04. Since we're not in the bottom 15% here, we're in the top, so we use the positive z-score. So then the extra part that's a little bit different here in this section than what we had before is we know the z-score value in this case. We had the z-score is 1.04. So we can use our z-score formula, plug in what we know for the z-score. In this case, we're trying to find the value. We're trying to find the GPA value. So remember, that's labeled as x. And then we can subtract the mean, once again, divided by the standard deviation, just like we did in the last section whenever we were doing this. But instead of knowing the value for x at this time, we know the value for the z-score, and we're trying to solve for x. So then it's an algebra problem. You're going to have to go through. You can multiply both sides by the 0.72 there to get rid of the denominator on the right side. And then those cancel out. So then we have x minus 2.7 on the right side. And then we're going to have to do the 0.72 times 1.04 on the left side. So if we do that here, we get 0.7488. So 0.7488 if you multiply those is equal to x minus 2.7. And then we're going to want to add 2.7 to both sides to finish getting x by itself. Because it was x minus 2.7, the opposite of subtracting is to add. So if we do that here, we get 3.4488 for the x. Remember, the x in this case is telling you what the minimum GPA you would need to be in the top 15% of this class. So you'd have to have at least a 3.45 approximately for the GPA there. So that would be what we'd be looking for then, for that GPA to be in the top 15%. So once again, this section here is still using the z-score stuff, but now you're going through and finding the z-score a little bit differently here. Instead of going through and calculating it, you're given an area or a percent or probability related to that, looking that up and then finding the corresponding z-score here.